There was quite a lot going on in question 2. You really had to work quite hard to get the marks here, but it was fairly doable. So in the first part, part A, we're asked to use interpolation to estimate the value of the median. So we are told that there are 32 students in the class. So in order to find the median, we're going to divide that by 2 and recognize that we need to find where the 16th student is. So if you want, you can put in a separate column for the cumulative frequency, or you can just work it out as you're going along. But you should be able to recognize that the 16th student is going to be in this category here. So we can then, again, I'd always advocate that you actually sketch this out because it's much easier to visualize. But we've got the situation now where we are trying to find the median, which corresponds to the 16th student. So we've got the boundaries here. We're going to have 14 students at the start of this boundary, and then we are going to have 25 at the end of the boundary. We've now got to figure out what the time is for these boundaries, and the key thing here is to recognize that because we've got continuous data. So if you look, this boundary here finishes at 39 and this one here starts at 40. So because it's continuous data, we've got to split it. So the lower boundary is actually going to be 39.5 and the upper boundary similarly is actually going to be 49.5. Now we can recognize that the difference between the median and 39.5, so if we take the median minus 39.5 and express that as a proportion of this whole distance here, which is 49.5 minus 39.5. That will be the same as this distance here, which is going to be 16 minus 14, which is 2, over this distance here, so 25 minus 14. So what we can do then is we can solve and rearrange that, and that will give us the median, which gives us a value of 41.3 to 1 decimal place. So that is the median in part 1 for 2 marks. In part B, we are asked to find both the mean and the standard deviation. And in fact, we're given here a lot of the information that we need. So we don't really need to even do the kind of long-winded table where we draw it all out. So let's start off by working out the mean. So we should recognize that the mean is going to be sigma t over n, which is going to be this 1,414 over 32, and that gives us a value of 44.12. So that's the mean. That's useful because the standard deviation, you should hopefully remember, is the variance, in fact, the variance is going to be the mean of the squares. So here that's going to be sigma t squared over n, the mean of the squares, minus the square of the means, and the mean is sigma t over n. So we're going to square that. So in this instance, that's going to be 69,378 over n, which we said was 32, minus, we can put in either the decimal or the actual fraction for accuracy. Is going to be 1,414 over 32 squared. Now this is the variance. So if we want to take the square root, we actually need to, if we want to take the standard deviation, we need to take the square root of this, because the standard deviation is the square root of that. And if we do that, we end up with an answer of 14.7. The final part of question 2 then, again, there was a question on skewness. And In the first instance, it looks like we've really got scant information here to use to find the skewness. However, let's look at what we do have. We found in part A that the median was 41.3, and we found in part B that the mean was 44.12. Now, if you remember that in the kind of perfect world where the data isn't skewed, the median and the mean will all have the same value. However, here, because we've got a value for the mean, which is greater than the median, we can say that that is positively skewed. Now, a way of thinking about this, the classic example is thinking about salaries, right? If you collected data on salaries of a large group of people, you would find essentially that you've got some kind of distribution that goes like kind of this, yeah? You're going to have some people way up here earning huge amounts of money, but they're going to be a very small number of people. But these people will affect the average. So if you look at the mean average will be artificially high because you've got billionaires here, and if you take that in, the mean average will be artificially higher. The better average, or more representative average, would be to take the median, which would be the middle piece of data. But the mean will be higher than the median, and we can see that the data is positively skewed as well from the graph here. So all we've got is the mean and the median, but because the mean is higher than the median, we can say that it is positively skewed.